It's a big day for us today. We are getting into what people think about when they think about Algebra 1. That topic is solving an equation for a variable, most commonly x. So that's kind of what we think about when we say, oh, Algebra 1. You think about solving equations. You were introduced to this idea way back in elementary school. So for that reason, we're bypassing over one-step equations and we're going straight to solving two-step equations. In the next lesson, we're going to go to multi-step equations. So we kind of push through this stuff pretty quickly because I'm hoping you already have a foundation of how to do this. But for today, we'll take it a little bit slow since it's the first time we're doing it. Now, when you're solving an equation for a variable, that is the whole goal here, you guys. You see the examples. All I'm trying to do is solve for x, solve for w. I'm trying to get the variable alone on one side of the equal sign. That is the whole goal. X represents some number. We talked about variables the other day. X represents some number in this equation. It has an equal sign. I want to know what x equals. Okay, to do that, we're not going to guess and check. We're going to do the inverse operation of what's being done to the variable, and we're going to do that on both sides of the equal sign. Okay, your equal sign separates your equation into like what's on the left side, what's on the right side. Now, inverse, make a little note maybe, that just means do the opposite. So what I mean by that, like adding and subtracting. Those would be opposite operations or inverse operations. Multiplying and dividing, those are inverse operations. So you're going to do the opposite of what's being done to the variable on both sides. Now, I want you to keep in mind that you can always check your answer when you're solving an equation. Okay, that is an amazing thing about math. You can check your answer. We're going to check all of these today. I would highly recommend doing that, especially on quizzes and tests. Now, we're just going to jump into some practice, and that's all we have. Okay, math takes practice, so that's exactly what we're going to do. You want to solve each equation for the variable, and we're going to check our answer to make sure we got it right. Now, I want you to make a note that to do this, we talked about the order of operations last time. To solve an equation, you do the reverse of the order of operations. So the reverse of PEMDAS. I'm going to give that a little highlight here. So when you're simplifying an expression, you do parentheses first, then exponents, so on and so forth. When you're solving an equation, you start at the end of PEMDAS and you work backwards. So I think about adding and subtracting first, and then multiplying and dividing, so on and so forth. So here's how that applies to example number 1. I want to get x by itself. Now, you hopefully don't need to do this, but if it's helpful, you can draw a vertical line through the equal sign, and that separates the two different sides. Okay, so like 2x plus 12, that's on the left-hand side of the equal sign. The 6, that's on the right-hand side. This applies to this second little bullet point. Whatever I do to one side, I have to do to the other side of that vertical line. So thinking about reverse order of operations, adding and subtracting first. My goal is to get x by itself. I need to move the 2, I need to move the 12 away from the x so I can get it alone. Now, you have to decide, do you move the 2 or the 12 first? Well, I know I need to address addition and subtraction first, so I'm adding 12 to x and I'm multiplying by 2. I'm going to take care of the adding and subtracting first by doing the inverse. So if I'm adding 12 to x, I need to do the opposite and subtract 12. Now, 12 minus 12 is 0, so I'm going to cross those off. Those will cancel. Whatever I do to one side, I have to do to the other. So I'm going to subtract 12 to the 6. Now, I'm going to highly recommend that you show your steps like that, okay, for 2 reasons. It helps you keep track of where you are, and it helps me see where you messed up. If you mess up, on the left side, The 12s are gone, so it's just 2x. Bring down your equal sign. On the right-hand side, 6 minus 12 is negative 6. All right, now I've got to get rid of this 2, and I'm done. So I know I'm multiplying by 2 when it's just 2x written next to each other. So I'm going to do the opposite, and I'm going to divide by 2. Use the fraction line. Don't use a little division symbol. Now, whatever I do to one side, I have to do on the other side to keep it all balanced. Over here, 2 divided by 2 is 1, so those just cancel. I cross it off, and I have x by itself. And then negative 6 divided by 2, that's 3. Negative 3. So I've got my answer. X equals negative 3. Now I'm going to go ahead and check it to see if I got this right. Here's how you check it. You're just going to plug in, and I know I use parentheses when I plug a number in. I'm going to plug in negative 3 where x was, and I'm going to do the order of operations. So 2 times negative 3 is negative 6 plus 12. Yes, that equals 6. It's the same on both sides. You got it right. Okay, example 2. So same thing. I'm going to draw the line. Do that if it helps you. If it doesn't, don't draw it. I need to get w alone. I have a fraction in front, which is being multiplied, and I'm subtracting 2. You undo addition and subtraction first. This time we were subtracting 2, so I need to add 2 to both sides. Negative 2 plus 2 is 0, so that cancels out. So bring down your 3/5 w on the right side, and I'll have 36 on the left. Now, here's my suggestion with the fraction. You won't have a calculator on this first exam, so you can't just plug this into your calculator. My advice is to not even treat this like a fraction. I take the w and I just put it on top with the 3. So I write it like this, 3w over 5. I don't know, maybe that doesn't help you, maybe it does. You have to get rid of the 3 and the 5. You gotta move them over to the other side. Hopefully you would do this. If not, get in the habit. If you're dividing everything by some number, that needs to be undone first before you can move the 3 on top. So if I'm dividing by 5, the opposite would be multiplying by 5. And I'm going to do the same thing to the other side. Okay, 5 divided by 5, that's 1. Those cancel. On the left-hand side, 5 times 36 is 180. And I just have 3w on the right. Now I can say, okay, I'm multiplying 3 times w, so I'm going to do the opposite and divide by 3 on both sides. 3's will cancel, and I have w equals, shortcut, 18 divided by 3 is 6. Add the 0 back on, so it's just 60. Notice how nice my work is. I showed every step. I crossed stuff off. I'm expecting that you do that exact same thing. Do not get lazy with your work from the 3rd lesson. It's not a good sign. Okay, so let's check it. Let's plug in. Whoa, okay, no, I did that good. Let's plug in 60 where w was, and let's see if I do actually get 34 on this side. Now, use your calculator to test this. Do it by hand, but it'd be 180 over 5. And then you subtract 2. That does work. You get 34 on the right-hand side. Okay, 36 minus 2, we're good. Yay, math, you can check it. Makes our lives easier. All right, number 3. So I'm going to draw my line. This one can trick people up. You need to get k by itself. Okay, you need to move the 6 to the other side. Now, it looks like you're subtracting, which you are, there is a subtraction sign. But people will confuse that and say, oh, let's add 6 to both sides. But when you move something, if they write the number first like this, you have to consider what the sign is in front of what you're trying to move. That's a positive 6. If I add 6 to that, I get 12. It doesn't go away, and I need it to go away. So since that's a plus 6, you have to actually subtract 6 from both sides. be very careful. On the left-hand side, see how that negative is in front of the k? I haven't gotten rid of that. That's still there. So it's negative k equals negative 4. If you don't know this, there's a 1 that sits in front of every variable. So there's a negative 1 in front of this k, and I'm multiplying by negative 1. So the opposite would be divide by negative 1. So my answer is actually k equals negative 4 divided by negative 1 is positive 4. And I can check it. If I plug in 4 where k was, yeah, 6 minus 4, that's 2. So I'm good. Number 4. Draw my line. My goal is to get h by itself, so the 4 and the negative 7 need to move to the other side. Now, reverse order of operations. Rule of thumb, whatever's connected to the variable, you move that last. So move the 4 last, get rid of the negative 7. Okay, remember to look at the sign in front of the number you're trying to move and do the opposite of that sign. So I'm going to add 7 on both sides. Don't just see addition and say subtract. It's the opposite of the sign in front. Negative 7 plus 7 is 0. Okay, so rewrite what you got left. I'm multiplying by 4, so I need to divide by 4. Do the inverse. And I get h equals negative 3. And let's go ahead and check it. So let's see, order of operations, 4 times negative 3 is negative 12. And that plus negative 7 is negative 19. Yay! All right, on the back, I want you guys to try both 5 and 6. We've done ones like them. Try them on your own. I will check them in class tomorrow. 7 and 8 I'm going to do, though. Okay, goal is to get n by itself. I need to move the 3 and the 7. Move what's not connected to the variable first. So the 3 is connected. I need to move the 7. So I'm going to add it. And I have m over 3 equals negative 3. Don't even think of this as a fraction. You're just dividing by 3. That's all the fraction line means. So do the opposite and multiply both sides by 3. And that'll give me m equaling negative 9, which I'm going to check. I'm going to plug that in where m sat in my original equation. Copy it over here. Do the division first. So negative 9 divided by 3 is negative 3. Minus 7, yep, that's negative 10. All right, last problem. This problem looks exactly the same, except the subtracting 7 is on top with the m. Now, this makes a difference. This is like an exception to your rule here. Don't you love that about math? There's like almost always an exception. There's an exception to doing like the reverse order of operations, and it's right here. Like I mentioned in a previous example, if everything on top is being divided by something, that number on bottom has to move first. So before you can break up the top by adding 7, you have to multiply both sides by 3 to get rid of those 3's. And don't actually multiply the top by 3. You just cancel out the 3's when you do that. 3 divided by 3 is 1. So I have m minus 7 on top equals negative 30. Now I can add 7 to both sides and get an answer of negative 23. So let's go ahead and check that. Same thing if I was just doing the order of operations here. I would have to figure out the numerator before I could divide by 3. So negative 23 minus 7 is negative 30. And when I divide that by 3, yep, that's negative 10. Okay, that's solving equations.